This is a wireless chapter for the Anchor exam. It covers a lot of ground. First, you will have to describe a lot of radio frequency terminology. Then you will have to describe what kind of antenna types are out there, the wireless client device capabilities, your access point discovery and join process, the access point modes, the layer 2 and layer 3 roaming scenarios, deployment types of your wireless LAN, and the location services. Remember that Wi-Fi has been defined using the microwave and radar band that goes from 1 GHz to 10 GHz. You have the 2.4 GHz bands and the 5 GHz band that has been used for several years by now, but recent standards will use other bands between the 1 GHz and 10 GHz spectrum. Remember how to calculate dBs. It's just the logarithm of a ratio. dBms is also the logarithm of a ratio, but the reference value is 1 milliwatt. dBis is a way to calculate antenna gain, where the antenna gain is compared with a theoretically isotropic antenna. And DVDs is the same, but the comparison is made with a dipole. You can translate between DVIs and DVDs with that formula. Remember how to calculate the effective isotropic radiated power. That includes the transmitted power, the cable loss, and the antenna gain. Remember the frame space path loss function that will calculate how a wave loses strength as it travels through the air. The more distance and frequency, the more loss it will experience. Remember what is the received signal strength indicator, what is the noise floor, how to calculate the signal to noise ratio, which is subtracting the noise floor from the received signal strength indicator. You need to know how to read radiation patterns using the H-plane or azimuth plane that is actually the XY plane and into 3D radiation pattern, and the E-plane or elevation or XZ plane is the XZ plane within the 3D radiation pattern. Remember what is the antenna gain, beamwidth, polarization. Remember that you have two types mainly of omnidirectional antennas, the dipole and the integrated omnidirectional. And the directional antennas will focus the radio frequency energy in one general direction, and you can have patch, Yagi, and dish antennas. Remember your device capabilities. What are your standards? .11b, GAN, AC, AX. What are the transmission rates and the bands? You must also remember what ZISO means, MIMO, spatial streams, transmit, beamforming, and maximal ratio combining is. What are the main modulation schemes used for Wi-Fi, and what is the dynamic rate shifting as a function of range. Remember your lightweight access point and discovery and join processes, including the access point states, boot, wireless LAN controller discovery, establishing the CAP-WAP tunnel, joining the wireless LAN controller, downloading an iOS image, downloading the config, being placed in run state, and eventually get reset. Regarding the discovery process, remember that broadcast is sent. Then you can configure up to 3 wireless LAN controllers manually in your access point. This is known as prime. Or your lightweight access point can remember up to 8 previously joined wireless LAN controllers. It can also use the option 43 for DHCP, or it can query the DNS server for the Cisco CAP-WAP controller hostname. Once it has the necessary information, the IP will select the wireless LAN controller to join to. It will first try to join previously joined or primed wireless LAN controller. Then it will try to join a wireless LAN controller that was the product of the discovery phase, and then it will try to join the least loaded wireless LAN controller. Once an access point has joined a wireless LAN controller, it can be put in several modes: local, monitor, flex connect, sniffer, row detector, bridge, flex plus bridge, and SE connect. For instance, if you have a network where the connection between the wireless LAN controller and the AP will rarely fail, use the local mode. If the otherwise, if the connection between the AP and the wireless LAN controller can get disrupted, use the flex connect mode. If you want to connect two sites together, use the bridge mode. If you are connected several APs together, but they are not connected to the wired network, use the bridge mode, and so on. Remember that when the roaming happens, your user is moving, and it is probably using several access points as it moves. Several things can happen. For instance, the users can require to acquire a new IP through a DHCP service that will be slow. The user can be asked to re-authenticate again. That can be slow and can affect voice calls. So Cisco offers some solutions to solve this, like the Cisco Centralized Key Management, Key Caching, and the standard .111. Remember that when your user is moving across your network, it can move through access points that belong to the same controller or to different controllers. If you move through access points that belong to the same controller, that is known as the intra-controller roaming. And if you're moving through access points that belong to different controllers, you will be doing an inter-controller roaming. There are two ways of doing inter-controller roaming. If you're moving to a different AP with a different controller, but using the same VLAN, you will be doing layer 2 inter-controller roaming. But if you're moving to a different AP with a different controller, and the VLAN is also different, you will be doing an inter-controller roaming for layer 3. In this case, an extra cobweb tunnel between controllers is established. You can also use mobility groups, where the wireless LAN controllers can be put together into groups, and the layer 2 and layer 3 roaming between these mobility groups is fast. But if you're roaming between different mobility groups, that process will be slow. And you can choose several deployment types: controllerless, where your access point will be in autonomous mode, or you can choose to use controllers. In case you choose to use a centralized solution, you will have a wireless LAN controller that lives in a specific box that can handle up to 6,000 access points. Or for your branches, you can choose to have an embedded controller. That means that the wireless controller is embedded in the switches, or the Mobility Express solution, where one wireless controller is embedded in one access point. You can also choose to use the cloud solution or deployment type that will involve using Meraki. Cisco offers location services, where it will provide you with the location of devices within your wireless network. For that matter, it will have to keep track of the received signal strength of these devices. 3 or more access points will be needed in order to triangulate the exact location of your end device. This is known for Cisco as the real-time location services, or RTLS. It would use access points, wireless LAN controllers, and a server or series of servers, including Cisco Prime DNA Center, Cisco Mobility Service Engine, Cisco Connected Mobile Experiences, and Cisco DNA Spaces.